In this video, I will show you how to complete part 4 of the project, which is using chi-square test. So we're going to use a chi-square test of independence to test the claim that mobile-only Facebook use depends on gender. That's our hypothesis. We want to check all the requirements for the test. So the requirements are that your expected counts are all at least 5. So we first have to compute the expected counts and double check that. So our null and alternative hypothesis, so H0 is going to be that gender and mobile only use are independent, in other words, not related. And then H1, which is actually what we're trying to show, is that mobile only and Facebook use depend on gender. So this will just be dependent. So independent or dependent. Select our level of significance. Step 2, that's given to us. Alpha is 0.05. Form the contingency table and then compute the test statistic is step 3. So first of all, we need to count of mobile-only users, how many male and female there are in the data, and not mobile-only users, how many male and female. So I've already counted those, but let me show you where this data comes from. So first of all, the 7 male mobile-only users. Now I'm using the example data, so your data will be different. But what you do is you're going to go look at this last column for mobile-only use, and we're looking at mobile-only users that are male. So you look at the yeses and count how many males are. That's a female. This one is a male, so that's 1, 2, 3, 4, 5. That's female, female, 6, female, 7, and I believe that's the end of the data. Yes, so there are 7 data values that are yes for mobile-only use and male for gender. So you're counting yes males. That is this 7 here. And then the 8, those are yes females. And then this 7 is no male and then no female. So no for mobile only use, and then count the males and count the females. So you'll count and put those expected counts in there, and then we are going to use the calculator to do the computation here. So first we have to input the matrix. So we're going to go to second matrix. We will do matrix, we want matrix A. So I'm going to go to edit, and there we go. And we're going to do 2 by 2. Accidentally clicked out. There we go. So our matrix A, we want to edit. There. So then we're going to arrow down here. So we want 7, 8, 7, 7. So 7. That's a 7. That's an 8. And that one's a 7. So those are our observed counts. And then we want to go to stat. Actually, let's go back to matrix here for a second. And we'll come to edit and enter. And then let's see here. I want to go back again. So I want to do B. We want to edit that one. And this will be 2 by 2. Okay, so there we go. So now we want to go to stat and then tests. And then we are going to do a chi-squared test of independence, which is just chi-squared test, option C. Observed are in A, expected it calculates in B. So we'll come down and we can do a calculate or draw, either one. So our chi-squared test statistic 032 and p-value 8575. So this chi-squared was 0.032. This p-value was 8575. But let's not get too far ahead of ourselves. Let's look at the expected counts here and make sure that we had no expected counts that were above 5. So we go into our matrix here, do second matrix again. We want to view here, so we'll go to edit and then come down to matrix B, which is our expected. And all of those counts are greater than 5. And let's go ahead and enter these values at least to a couple decimal places into the spreadsheet, or into our matrix here. So 7.24, 7.76. And then the expected counts in the non-mobile only, 6.76, 7.24. So, and do yours the same way. So count, put your observed in there, and then put your expected in parentheses beside it. So our chi-squared test statistic was 0.032. Our p-value is 0.8575. If your p-value is less than significance level, we'll reject the null. Since our p, which is 0.8575, is greater than 0.05, we do not reject. So we're not going to reject H0. So, and then we want to state our conclusion to finish up. So if you do not reject, that means that there is not sufficient evidence to conclude the alternative hypothesis, which is gender and mobile only are dependent. Oh, and then, yeah, we forgot to put a yes up here for our condition. We did check that. All our expected counts here, all 4 of these expected counts in decimals are greater than 5. Now, if by chance you ended up with one of these being less than 5, go ahead and run the test anyways for the practice of it. So I just want you to get a chance working with some actual data.